together all the common questions. So go for a question from different languages. This just tends to be the most common question. Why isn't 0.1 or 0.2 exactly equal to 0.3? Because it is very deep, right? Next mistake. Arrays in JavaScript are very useful type arrays. If you go and delete an element in the middle, the array does not collapse into one element short. It stays the same length, and what you end up with is a strange hole in the middle of the array. No one has any use for this behavior at all. It just falls out of other decisions in the language. But you have to relate to it some way. Even stranger, there's an undefined value that you get when you go and look for something and there's nothing there. But when you delete something in the middle of the array like this, the result of the deletion is not that the array now contains an undefined value. It literally contains a hole with nothing there, not even undefined. So when you compare it to undefined, it's also not true. It's very, very weird. And there are explanations for this behavior. I mean, if you want to talk to Random Mike about this, he could explain to you exactly why that happened. But still, it's very useless, especially since probably the most commonly used for arrays in JavaScript is still when you're working with an HTML software and you say, get me the children of this node here, and I think that will be an array of children, and that array will always be compact, right? It will never be sparse. If you look in sort of all possible applications, there might be some really cool uses of sparse arrays, but it's not the common use in JavaScript, and it's just distracting that this is the first thing that the user needs. Next problem. If you fail to explicitly declare a variable, here we could have written var foo equals 5 to declare the variable. If you don't declare it, even if it's deep inside a function, sort of in the middle of your program, it ends up as a global variable for the whole program. Now it's shared with exactly everything else in the rest of the program. So the next time you do this, or the next time you access foo, you risk getting exactly the same value here. So you can, in the worst case, share variables between completely separated, completely distant parts of your program. Some people call this spooky action at a distance. It's a term borrowed from quantum theory and theory of relativity. Hold on, excuse me, just going to mute this. It's almost spooky. So, and you know, if we take a step back, why does JavaScript have this default? We'll come back to that topic, of course, but it's because JavaScript was meant for really, really small things. And if you are a newcomer and if you don't really care about declaring your variables, then it's kind of cozy and convenient that this works. You just name a variable that you happen to think of, you don't have to declare it, and it still works. So in a really, really small environment for solving really, really small problems, this is actually a benefit. And in 1995, no one thought much of this as a problem. It just became a problem later on as the demand in the language rose and increased. Next one. When you do this 4 plus the string 2, you probably expect 2 to be converted to a number and you get 6 back. But no, not in JavaScript. The string always wins. If one of the sides here of the plus is a string, then everything turns into a string. Then you get string concatenation. So yes, in fact, the plus here is used for 2 completely separate things. Arithmetic addition, like we're used to, and string concatenation. There are not 2 separate operators for this. There is one single one. And it does different things based on the inputs that it gets on both sides. Right? Here it's easy to see because we have the constant values on both sides, but usually these are variables and then it's really difficult to see. This behavior is borrowed from Java, which also does this. It does arithmetic addition with a plus when it gets numbers in, and it does string concatenation when it gets strings in. And you can mix them even in Java and then string wins. So the behavior is taken straight from there. But the big difference is that Java is a strictly typed language. It does type inference, and you always know in the end, even before you run the program, what type you end up with. In JavaScript, you have no such guarantees because everything is very dynamic and very late-bound, and it might even differ, from run to run. If this is in a function and these are variables, it depends on what parameters were passed in. So one time you're calling a function, you will get a number back, and one time you're calling a function, you will get a string back. It's very unpredictable and very hard to reason about. So this is also one of these mistakes that came back to bite JavaScript, and a thing that we, to be honest, are struggling with. So some people are proposing adding a separate concatenation operator and so on. That hasn't really happened. So yeah, frustrating. I've seen people fall into this trap during live demos with technologies involving JavaScript, and they get something like a string object and then one afterwards, and that was not what they intended. Other things that went on in JavaScript, Netscape also dabbled in a technology that they call server-side JavaScript. Very, very forward to do this in 1995. Someone tweeted this image and said, gee, I have no idea why this never took off. Because if you look carefully at what this is doing, it actually has a server tag with capital letters where you put your server code. And you can imagine that the ergonomics of this are not very great, actually. So it was an early attempt. It didn't get anywhere. It got shut down fairly soon. But it actually, again, in the rear-view mirror, serves the promise of what we do now today and what we have succeeded with. So it's kind of fun to see. Meanwhile, over at Microsoft, there was probably some kind of panic, because now Netscape actually were on the market with dynamic scripting language for their browser. And what was Microsoft to do? Well, they had to come up with something similar, right? And they saw that people will want JavaScript now that they have seen it in Netscape Navigator. So let's do something similar. So in their Internet Explorer 3, yeah, IE 3, that's ages ago, they actually released the sort of early attempt at a scripting language. They couldn't call it JavaScript because of trademark infringement reasons. So they went cheeky and called it JScript. So JScript was exactly the same as JavaScript. In fact, this has later been considered Microsoft's very best attempt at reverse engineering ever. So they must have gone into the room, they don't have the source code for this JavaScript thing, but they sort of poke at it and try it in every single way, and then they re-implement the whole thing in exactly the same way, as we say in the industry, bug for bug. Because, believe me, there were early mistakes in that. And so now we had two largely feature-compatible scripting engines running each browser in Explorer and in Netscape. And Microsoft started to take the lead here and started to innovate as well. So they started in IE4, they pushed for the term dynamic HTML. This is also a foretelling of what's to come. Dynamic HTML is simply the idea that you can enhance your HTML by making it move around in nice ways and sort of react to your mouse pointer, and when you click, it's not just a link behavior, it could be basically anything, and you can have animated colors and a lot of things we take for granted with CSS today, you could do with JavaScript, for example. When I got into serious work with web development, CSS was still not so advanced, and we still did our zebra coloring of table rows with JavaScript instead of CSS. And so dynamic HTML was simply HTML plus JavaScript. But since they really used it in JavaScript, they set the true system. Now it was Netscape started to find it again because they knew about Microsoft's tendency to embrace the technology, to extend it in their own way, and then to extinguish the competition by making these extensions so desirable that you don't want to use the competition anymore. So that's a concrete strategy that was used in the 90s at Explainer. So embrace, extend, and extinguish. So Netscape ran away to extend its body. Take International, actually across the ocean from where all this was going on. This is a European Computing Machinery Association, if I remember correctly. And they said, we have to standardize this language so that our competitors cannot do anything funny with it. There has to be a standard that you adhere to when you implement this language. And ECMA said, sure, we'll help you with that. Of course, we'll invite all the parties that are involved here. So Netscape had a place at the table and Microsoft had a place at the table and so on. ECMA was in a little bit of a bind because they couldn't call the language in the standard JavaScript. That was Netscape's name, and you couldn't call it JScript for similar reasons. So in a fantastic sort of, we'll just leave this suggestion here, moment in history, they called it ECMAScript, and the name stuck. So the actual name of JavaScript, the language, is ECMAScript. Whenever we talk about versions of JavaScript, we say ECMAScript 3, ECMAScript 5, ECMAScript 6, and so on. It's a horrible name. I'll just be honest with that. It sounds like a skin product. But that's really there was also some, interesting action at that table when they had their meetings and decided what should go into the spec. Because from Netscape's point of view was, okay, good, now we can finally fix some of these early errors that came in the first 10 days and we can make a better language, as long as we're specifying anyway. And Microsoft said, hold on, no. We have users. There's one thing you do not do, and this became a slogan for later users of JavaScript and later thinking about JavaScript. There's one thing you do not do. You do not break the web. So everything that's out there already has to be supported. We hear you when you say that the language contains warts and for early errors, but we live with that. We put that into the spec. We put the bugs into the spec, and then we live with them forever. So that's what they have to do. And for once, again, in retrospect, this was Microsoft being difficult here, but they were also right. You do not break the web. That's one of the actual rules here. Of course, this meant that we now have kind of a problem, and not least because there are new browsers out there and there are old browsers out there. The language is horrible, and there are old versions of the language which are even more horrible. If you want to write ECMAScript 5, a relatively new version a couple of years ago, and you know that at least one customer will visit your page and have a browser that only supports ECMAScript 3, well then you're stuck with writing ECMAScript 3. No matter what you want to write, it's not a matter of sort of, you cannot upgrade your version because the code runs. This is just part of it. You have to write to the lowest common denominator. And this kept being a problem for a long time. And it's only in this decade that we have really overcome that. And it's really nice. So that was the 90s, briefly. We have now sort of lived through the first browser war. And things start to settle. Things start to become a little bit more consistent between browsers and so on. Because at this time you often had the problem that you tried to implement something in Netscape and then you tried it in Internet Explorer and it completely broke because some API or some function call didn't work exactly the same way, or you had to use some other function. People did a lot of browser detection at that point, the equivalent of saying, yes, I'm in Internet Explorer, but you have to put something really creative and funny in the collision to figure out that you're in Internet Explorer. That's now not a recommended practice at all. Why? Because browsers evolve too, so you cannot sort of take just the name of the browser or just some significant hint about the browser for granted. It keeps changing over time, and then your code breaks if it works. So what we do nowadays is feature detection. Basically, the feature you're going to use, you put that in the if statement, just checking away. If it's there, good, then then we can use it. If it's not, then we have to compensate somehow, or load the feature manually, or do some lower level feature or whatever. But that's also something that we have learned along the way. And I have no idea. Alright, we're going to 15 more minutes. Moving on to the next decade. So at this point we have lived for 5 years with JavaScript, and it's important to think back at JavaScript's role and its intended use here. This was not a serious language. This was not a big language that people had big hopes for. It was not a billion-dollar industry or anything. I like this quote. The by design purpose of JavaScript was to make the monkey dance when you mouse over it. So scripts are often a single line. That was the sort of silent complexity of what you wrote. We considered 10-line scripts to be pretty normal, 100-line scripts to be huge, and 1,000-line scripts to be unheard of. You just didn't do that with JavaScript. It was theoretically capable of it, but no one would have the source even. Nowadays, 1,000 lines is nothing, so something has happened along the way. There's also, just in the names of things that we use here, a lot of cultural baggage. When we say scripting language, it means a lot of things. It means, it's slow because scripting languages are accepted right across the board. That's actually not entirely true, but that's the view of it. It's not a serious language. The scripting language is this frivolous thing that you use maybe at home after you quit your programming job for the day and go home and you sort of do toy stuff instead of the serious business enterprise things that you do at work with the real languages. So scripting languages are those, maybe you can solve the problem quickly in a scripting language, or maybe it's even pretty fun and cool to work with and so on. But it's not real work. It's not what you do when you actually make money for your employer. Scripting languages are sort of lower class in that sense. And this is something that we have also completely turned with JavaScript since then. Sure, it's in the name, JavaScript, but nowadays we cannot consider it purely a scripting language because really JavaScript is used for everything. By the way, let's stop and talk about the name for a while. It was totally a marketing stunt, which is why it's called JavaScript. The original name was Mocha, so there was already the sort of coffee theme in there, probably because of Java. And then for a while, at its release, even in Netscape Navigator, it was called LiveScript, which is actually a good name for the language. And then for marketing reasons, I guess the PR people called up and said, no, we're going to call it JavaScript, because Java is very popular right now, back in 1995. And so JavaScript will be sort of pushed as a little kid brother to Java, like Batman's Robin. Sort of Batman handles all the big serious business stuff, and JavaScript handles all the little sort of quick, not so serious things on the side. And you may even remember applets on web pages, and that was sort of an attempt at the screen. Inside of your applet, you have the real programs in the web page, and then on the rest of the page, JavaScript could sort of run around and help a little bit, but it wasn't doing anything serious or anything important. It's funny how at this point, JavaScript has effectively killed not just Java on the web in the form of applets, but also Flash. And both for fairly similar reasons. When you sort of put a rectangle in your page with a different environment in it, be it Java or Flash, it has real trouble integrating with the rest of the page, and that eventually killed it. With JavaScript, you're right on the page. You're integrated with everything. You have access to the structure. You can talk to the user. Everything's great. I mean, applets were struggling even with the issue of focus. Sometimes you type things in and you were not in the applet and your keystrokes were just lost. So that was difficult for it. So in this era of, let's say, 1999 to 2004 or 2005, something like that, nothing much happened with JavaScript, but things were stabilizing. The dust was settling from the browser wars. And that was a good thing in itself because it gave a little bit of stability to the browsers. And then something turned up which sort of turned things on its head, and it was called Ajax. Now, Ajax is also nothing new. It's just the idea that, hey, maybe you don't have to reload your page so much. Because if you have a dynamic language in your browser on your page, it can go and get more information and actually change your page around and maybe replace some content and do some fun stuff. So you actually don't have to do a full reload of the page. That's kind of wasteful. So Ajax came in 2004, 2005, something like that, just as a concept. And the funny thing there historically is that the concept was just the name. All the technologies had been there since 1999. We were just waiting for someone to have a realization, and we were waiting for the stability in browsers to allow us to actually do this across the board in a meaningful, useful way in all the browsers. Next up, we were all surprised by Gmail that showed up and used this famous technology. Gmail was one of the first serious apps that actually stayed on the same page all the time. So when you went between your inbox and your start folder and your send folder and so on, this is how Gmail used to what it actually did, instead of reloading the whole page, it was putting a lot of iframes in front of you, like taking big paintings and just not sliding them, but putting them instantly in front of you. I think it even changed around settings so that they were jumping the right one to the front. Really innovative and really cool. I'm pretty sure it doesn't do it that way anymore, but it did back in 2004. Eventually, Gmail even got their URLs right, so as you went around in this Gmail application, it felt like you were actually visiting different pages. Of course, that's all a lie, because you get this progress bar with loading the first time you open it, and then you stay inside the app. So you get the best of both worlds. So you feel like you're visiting different pages inside your Gmail app, but it doesn't have to reload the whole thing, because it's actually staying on the same page. And that's all thanks to Ajax, which is simply the realization, not even a technology as such, simply the realization that you can send a background request to the server for data. It doesn't give you necessarily HTML back, it gives you the data to build the new HTML that you want to show to the user. Really, really powerful, and allows you to stop thinking about HTML as just a document and start thinking about it more as an app. There was great resistance to this idea, by the way, I should say. There were many people who wanted it to be a document. HTML came about in CERN, Swiss scientific institute, where the intended use of HTML was simply to write up abstracts which could link to each other and refer to other abstracts. What do you need for that? Well, you need for heading, paragraphs, lists, and links, and then you specify HTML. So these people were looking at things like Ajax, and they were horrified, and they said, what are you doing? You're creating a monster here. And eventually, over the years, the app people sort of won out. But it has been a struggle, sort of with standards bodies and so on, to actually make the app people win there, because some people simply didn't feel that HTML should be dragged in that direction. All right. Next important person. Jon Rettig is important because he has contributed the most influential JavaScript library to the world. Anyone know which one? Yeah, jQuery. So, and the tagline here, write less do more, is entirely apt as well. jQuery came in as actually a pleasant way to do JavaScript. And when I go out teaching, there are so many times when I encounter people saying, coming to our courses and so on, well, I use a lot of jQuery, but I don't really know JavaScript that well. Which to me is, kind of funny or weird, actually. I don't see people saying that about different languages and libraries. If you use a library in a language, you're usually fairly familiar with the underlying language too. But not with JavaScript and not with jQuery. And this tells you something about the position of jQuery and why it's so popular. It actually enabled more or less total beginners to come in and be productive with JavaScript and use it in ways that make sense. Nowadays we know of a number of ways in which jQuery is sort of not enough to build big applications and so on, but it's still very, very successful in what it does. It allows you to just go in and write a little bit of code, and the code is sort of even pretty and fun to write, and it does what you want, and then you jump out of it again and you provide. It's kind of like Excel in that way. Excel allows people to be programmers without really being programmers. So does jQuery. You go in and you type something, and if it looks right, then probably it works too. And that's pretty impressive for a library to do, actually. There was the idea here of progressive enhancement. When you build a page, you build it as pure HTML, you can lay on CSS so it looks nice, but there you sort of pause and say, this is good enough. Now you have your links that actually take you to other places, no Ajax or anything like that. And then if the browser is capable enough, it goes on and loads from JavaScript, which enhances this, and for example, can make a link stop going to another page and start doing Ajax instead, so it's kind of more capable. But this could happen sort of from the bottom and up. You always build thinking that people do not have the advanced features, and you build the page very simple, and then you layer on the more advanced features. It's not just JavaScript off or JavaScript on, it's also all the other technologies that come after JavaScript. So do you have geolocation or not? Well, if you do, we can do cool things with that. If not, then we skip it. Or do you have speech recognition, or do you have flashlight on the device that we have access to, or whatever. Progressive enhancement says we start with a simple thing, and then we layer on the advanced thing and an optional extra. And that was kind of a big thing to realize as well. The previous image of this had been earlier something called graceful degradation, which is the opposite way of thinking. So for example, either you support images and then you can show the image array, or it has to degrade gracefully and do something sensible when there is no image support. It shows some text instead and so on. Well, it turns out because people are comfortable, if you start thinking like that, people handle the image case, but they don't handle the no image case. So that didn't really work out in practice. People don't like to have to think from the top and then support a bunch of less capable things. That didn't actually work. Nowadays, every day, jQuery is being made a little bit more unnecessary in the world, a little bit more obsolete. It's still widely popular, and if you go to a web page, a big web page, it's more likely to use jQuery than not to use it. But it is getting crowded in that niche, probably mostly because browsers are actually implementing all the things that jQuery provided. To me, I would still choose jQuery in many situations, simply because it's a matter of it's a trade-off between the time it takes for the programmer to reach a result and raw performance that can get without directly with JavaScript without jQuery. Well, to me, the raw performance is not usually what I'm optimizing for. Getting results done and sort of getting a feature in place is what I value, and so I take the shortcuts with jQuery. All right, we've gone almost 45 minutes. Is this a good time for a break? Yes, we can take a break here. Okay, great. So we will await the pizza, and after the break we will come back and talk about Douglas Crockford and his kind of stuff.